Hi friends, welcome to my channel. Let's have a look at problem 1254, number of closed islands. So in this video, we're going to share a method or solution based on traversal. So we're going to present both breadth-first search and depth-first search. So the difference of this problem from other problem is that we need to count the number of closed islands. So here, a closed island is an island totally surrounded by ones in 4 directions. So let's look at some examples. So notice that here 0 is land and 1 is water. So in example 1, the return is 2. So here the gray areas depicted the islands. So this is 1, this is 1. So this corner zeros and this corner zeros are not closed island, right? So the return is 2. So let's look at the constraints. So the length or the number of rows or the number of columns of the grid is bounded by above by 100, below by 1. So the grid ij are integers, so either 0 or 1. 0 means land and 1 means water. So with that said, let's look at the analysis and give a quick solution. So in between, we're going to go over the code line by line. So the method is a standard traversal methods or algorithms. So here, what's the difference of this problem here? As we mentioned when we read through the problem, that is a closed island. So as specified by the problem, a closed island is an island totally surrounded by 1 in 4 directions. So the key point for this problem is that how to write the above logic to the code. So actually it's very simple. So one way is that we add a check in the traversal process. So we'll demonstrate this point. And a question is that because this is another problem of locating connected components but with some extra condition. So can you write a solution with disjoint set data structure? So with that said, let's look at the code. So I'll split the code into several parts so that we can make the logic or structure clear. So first, I'm going to get some meta information. So that is the number of rows, the number of columns, the grid, length of grid 0. So this part is very straightforward. So next, what we want to do is that we want to write some hyperfunction, some traversal hyperfunction. So here I'm going to write a function. I'll call it traverse. The reason I call it traverse, it means that this function can be either breadth-first search or depth-first search. So it accepts coordinates. And then also I want to mark if this island is closed or not closed. So an island is closed if the land does not touch the boundary, right? Based on the problem assumption. So for that, I'm going to introduce a variable called valid, which is a flag variable or boolean. So its initial state is true. And then we want to initialize a visited set. So this set is going to be a representation of the coordinate of the connected components. So which will store the coordinates in the connected components. So then we want to specify some container. So here this container can be either queue or a stack. So let me write in an iterative way. So we initialize use this argument position, that is ij. So with that said, we are ready to do the traversal. This is a while loop, while container. First, we're going to get the position from the container pop. So here, pop, we can pop from the tail, or we can pop from the head. So if we pop like this is the DFS. So if we pop from 0, so we are using the container as a queue, that is BFS. So with that said, let's first add the current position to visited site. Right. So then I want to add a logic check for if the island is closed or not. So if r in 0 or m-1, in other words, if r is in the or c in c0 n-1, in total the position says that the logic says that if r and c is a position in the boundary, then I'm going to mark this valid to be false. So that's the check, right? So we can tell if an island or connected component is closed or not in the sense of this problem. So next is a standard traversal. So we look at the neighbors. So r minus 1 c, r plus 1 c, r c minus 1, r c plus 1. So let's do a quick check. R minus 1 c, r plus 1 c, r c minus 1, and r c plus 1. That's good. And then we want to check if this position is in range and it's a land and not visited yet. So if 0 less or equal than x less than m and 0 less or equal than y less than n, and so the grid xy is a land. So here the land means it's 0, and also we need to make sure this position not visited, not in visited. So actually for this check, not visited or not, so we can do a check in here before we add to the visited site, or we can check here. We just need to check once. So once we do this, so let me make sure the indentation is correct. Then we are going to append this to the container. So container append, so xy. So that's it, I guess. So now what we want to return actually is, first, if it's a valid island. Second, the corresponding connected component. So even if it's not valid, so we have visited that coordinates, so we do not need to visit it again. So that's the logic. That's why we return a tuple. One is a flag, one is the representation of the connected component. So that's the main task. So next, we just need to count, right? So for that purpose, let me introduce a variable called count, initially 0, and we want to return its final state. And also I want to use a set to monitor the process so that we avoid repetition. Then we're going to do a for loop for I in range m, for j in range m. Then what we are going to do is to check if grid ij is land and ij not in visited. So if visited, we do not need to repeat, right? So then we're going to do a traversal. So that's valid, and s is traverse this ij. So let's see, right? And then we want to check if valid. So we are going to increment the count by 1. Otherwise, we do nothing. But in any case, we are going to enlarge the visited site by union with the current positions we have visited, so that we do not need to visit them a second time. So that's the full code. Now let's return the count, right? So let's do a special case check first. Oh yeah, it passes a very special case. Now let's do a generic case check. Yeah, it passes the generic case. So here we are popping from the tail. So we are using stack, that is depth first search. Let's do breadth first search. It also passes, but looks like the depth first search is a little bit faster. All right. Anyway, so that's it for this problem. I guess the thing in the distinction for this problem is that we want to count the closed island. In other words, we want to count the connected component, but not all the connected component. So we write this logic in the traverse function itself, and that's a treatment, one of the treatment. Actually, we can treat this logic in different formats, but you can, I guess you can try. With that said, I guess that's it for this video. Thank you so much.